Hello, Vivek. Namaste. Hello,
Yeah.
Vivek. Namaste. Hello.
Everyone has joined. Uh, Hello, Anuradha. Can you hear us? Am I audible? Hello, everyone. Am I audible?
Yes, sir.
Yes, yes.
Okay. I think perhaps there's an issue with Professor Anuradha. Hello, Anuradha. Am I audible?
Yes, you are audible.
Huh. Oh, that's great. That's great. I thought
Yeah.
perhaps my voice is not reaching. So, should
No,
we start?
yeah, there seems to be a slight problem at my end because I am not getting the audio on my main screen. So maybe I'll have to use my phone for audio and the computer for
Or do you
this
want to
thing.
restart your machine and check it once? We can wait for 10
No,
minutes. No.
no, this issue seems to be there for the last few days. So I don't
Okay,
think
okay.
there's any point wasting time in that.
Okay, okay.
Yeah.
So let me just check if everybody has joined. Yeah, everyone is here, so we are good to start. Uh, Good morning, friends. I hope I'm audible. If I'm not audible, please let me know. Uh, I'm very happy, and it's kind of a privilege to introduce Anuradha. Anuradha Patnaik, Dr. Anuradha Patnaik, is a PhD from IIT Mumbai, IIT Bombay, as they say it. Uh, and that's not her like that. That's her basic introduction. She was a gold medalist uh, during her masters. So she had GRF for her PhD. She had many scholarships to her credit. I won't read everything, but she is a very active researcher. She has multiple publications to her credit. She has written book chapters to some very important publishers like Springer. Springer. She has written a book chapter on. She had published papers in variety of areas, uh, and perhaps some of the important ones would be disintegrate food inflation in India, or monetary policy transmission in uh, India, and several other uh, important journals. She had made contributions. She is excellent econometrician. She is like, if I have any doubts, one person I can close my eyes and go and talk to is Anuradha. I must say, for one of the recent paper that I was doing using time series with a lot of my colleagues in uh, other countries, I was doing time series using that data, and that was my first time I did time series with any of the data, and she was such a great help. Like, anything I had a doubt with, and I would perhaps, Anuradha, can I talk to you? And she would be readily available within an hour to resolve the problem. The moment you tell her the problem, uh, it's amazing. Like, she would tell you, these are the 5 papers you need to read, out of which uh, uh, this particular paper is most central. These are the R packages. To understand theory in depth, this is the book chapter you should be reading, or this is the book you should be referring to. And that's not just for one problem. Any problem that I uh, went with to her, she was, number one, very kind, approachable, friendly, but at the same time very competent. uh, in solving problems. And you know, uh, I often, whenever I think of Anuradha, I think of Susan Fisk's theory of competence and warmth. And that theory says that when people are perceived as competent, they're often not perceived as warm. And when people are perceived as warm, they're not perceived as competent. Uh, Anuradha is one of the exception for that theory. Uh, she is warm, friendly, but at the same time, a lady of great competence. I am very happy personally. I'm very glad that I have colleagues in other departments who are having such a great competence. Anuradha, we are delighted to have you here for this workshop. She agreed to talk to us at a comparatively shorter notice, so I am thankful to her for that as well. She's going to talk to us on logistic regression and other similar models for ordinal data uh, or nominal data. She's a great expert in this area, and I must say she's a wonderful teacher. I have attended several sessions she had taken, and she's a great teacher. Such an organized person she is when she teaches. This is one trait personally I think I should learn from her. I always feel that being very organized a teacher and being very student centric, and that's something you would experience through her session. uh, Thank you, Anuradha, for joining, and it's all yours.
Very good morning, Professor Belekar, and thank you for such a generous introduction. Basically, I'll just give it a try what I can do, because there seems to be issues at my end, technical issues. So I don't know how far I'll be able to manage everything, but I'll see to it that there are no major problems. And yeah, thanks a lot, sir, for giving me an opportunity to meet a completely different set of people, because we normally meet people from our field, so all are economists, and it's very different to actually, interact with interdisciplinary, or have interdisciplinary discussions that always uh, pays us. So there's lots to learn for us also from you all, and so it's like mutual. So whenever Professor Belekar asks something to me, I also understand that okay, my model can be used, or my technique can be used in this field also, which is very interesting actually. So yeah, so I think I'll start my this thing lecture. Before that, I'll be sharing my screen. Um, uh, Please let me know if you all are able to see my screen, so that I can proceed. Uh, can you all see my screen?
Yes,
Yes.
Yes, it
yes.
is visible.
Yes. Okay. Yeah. Thank you so much. So, uh, basically, what I plan to do in today's session is like I've been allotted 3 hours time. So I was just trying to plan out how to go about with it. So my plan basically is to first introduce some kind of data structures, uh, because basically it is a data structure only which tells you which kind of model has to be picked up. So I will initially introduce some kind of data structures. Then I will just try to introduce some of these models in a very non-technical manner. So maybe like, I will do a logic model, then Probit model. I may introduce a Tobit model, and if time permits, I may go in for multinomial. So this will be the theory component, and After doing the theory, maybe the next session can be an R session. So I just wanted to know before proceeding further, do you all have R Studio on your systems? Will
Yes.
you be able to?
Yes, ma'am.
Yeah, so we can do it simultaneously when I'm doing over here. So what I'll do is when we take a break, we'll be able to take a break, no, in between, a 10-minute break.
Yes, around 11:30 we will have a break till 11:40, 11:45.
Yeah. So in the meantime, what I do is I will mail a data set which can be used by, like, if the data set is the same data set, then we all will be able to get the similar results. So we can do some coding on R and have a hands-on experience of it. Okay, can I proceed? Can I start with the session? Okay. Basically, I just wanted to know if it would be great if it's an interactive session. So if it would be nice if some of you all tell me about the kind of data work that you do.
Yeah, Anuradha, Umesh here.
Hi, hi.
Yeah, hi. Good morning.
Yeah, I
During
can
my
see you in the car.
yeah, thank you, thank you. Actually, during my MPhil at JNU, so I had run logistic regression, but
Yeah.
it was almost 10 years back. So since then, I haven't used this logistic regression. So it would be really interesting and refreshing to just refresh those ideas. I'm looking forward to it.
Yeah, sure, sure. But will somebody give me some kind of example? Like if you used logistic regression, what was the basic motivation point for using a logistic regression? Did you have anything in your mind at that time?
Yeah, because my dependent variable was dichotomous, whether the students will go for higher education or not. So that was the
Exactly.
outcome or the dependent variable. That's why the best model I thought was the logistic one.
Okay, great. So, like basically in psychology, how much of this kind of stuff y'all are doing? Like y'all are very much into all the regression models, or it's like whenever your data demands it comes up.
Uh, can I quickly come in?
Yeah.
What happens, Anuradha, and that's my general observation, and so let's not go to a specific issue, and that is people use multiple linear regression model more often. Then
Okay.
they use what we refer to as mediation moderation variable regression, wherein basically there's one more variable. So two-step regression is done,
Yeah.
and then variance components are extracted. Uh, uh, so you predict y from x, then you predict z from x, and you predict y from z, and then each of the component is separated, is what is done in mediation, slightly similarly in moderation. So that's done. Logistic models are comparatively less used, wherein the Likert scale data that most social scientists use and psychologists in particular use more often, where responses are from strongly agree to strongly disagree scale, where it's not just binomial but kind of multinomial. Often people consider it as a continuous random variable when in reality it's a discrete,
This.
and they often have little understanding of what kind of models are most appropriate for this. So, quite a few papers would do uh, uh, multiple regression, even in this case, and things like that. Perhaps I would say Umesh is a exception and not a rule. That's
Okay.
what I wanted to say.
So I think I know where to start from. I'll just I kind of understood that there is understanding of regression models and there is an introduction to it. So I'll start from a slightly different this thing. Uh, so basically, when I have to start this modeling and all those things, the first step in this kind of analysis is we look at our dependent variable. And we also have, like for any kind of regression models, you would have a dependent variable, which is normally denoted. It's like a convention to use YT. T is like if you have a time series data set. Now here we are not looking out for a time series data set. We are looking into a cross section. So I'll remove the T. Yeah, so if the dependent variable is suppose denoted as Y, and we have a host of explanatory variables, or there are different ways of calling this. This will be either the predictor variable or explanatory variable, whatever. So we will denote them as x1, x2, x3, and so on. Now, basically, when we are so these are all my explanatory variables. Okay, my explanatory variables and my dependent variables taken together, I can have a regression model where I have y is equal to a function of all these explanatory variables. So this will give me my regression model. And the most important part of the regression model comes when you have y is equal to say beta 1 x1 plus beta 2 x2 like this till beta k xk, and then plus you have an error term. So I am so used to putting a T subscript because of my time series orientation. Yeah, so you have a U, which is the error term. This is the basic structure of a regression model. And this is where we actually start thinking about it. Over here, I have consciously not introduced a intercept or a constant because that has other kinds of implications. So what happens is when you are basically doing a multiple linear regression model, you have certain assumptions relating to your U. These assumptions relating your U are very crucial because only if those assumptions are being followed, only if those assumptions are met with, your predictions will be correct. So basically, it is this part which is very important. But if you just want to see what is a regression model looking like, then let me just put it in different colors. This part is the dependent variable. This part is called as the portion that has been estimated by us. Like when we run the regression model, we will estimate this. And this part is called as the residual of regression. So we normally denote this as y is equal to y estimated plus u, which comes from this regression model. So we put a hat over here only. So basically, this part is something that we need to really analyze in terms of what we are getting here, what is the behavior or how this is behaving, and what is the nature of y. Before starting any kind of research which involves data, whether it is primary or secondary, you need to understand the data structure, because if you do not understand the data structure, you get into problem of picking up the wrong regression model, or you get into the problem of not being able to understand what are the problems in this kind of data sets. So the first step is always to know whether a particular data set is in the form of a multiple linear regression model, or there is something else that I am supposed to do. Now, what happens if I go with a multiple linear regression model when my y variable is categorical? That is something we need to look at. But before that, we always assume that when I'm doing a regression model, I will say that my y variable, my x variables, etc., all are continuous variables. Continuous means they can take any values within whatever range. So the range can depend upon the kind of variable that you're taking into consideration. They can take all values. That's a very wonderful situation. It's a very comfortable situation because all the distributional properties and all become well defined if the variables are continuous. But that doesn't mean that if you have discrete variables, it's a problem. You have adequate techniques to handle these situations. Now,
Are you
I'll
st-
just give you
are you still presenting? Because I could not see the presentation.
what happened. I was still presenting. I'm still
Your screen is not visible on the
my network has gone. Department network is gone. Just give me 5 minutes. I think some problem.
No problem. Yeah.
There is connectivity issue here.
No issues. No issues. You take your time.
So I'll talk by the time this internet connectivity works. You are working from the department, Professor Belekar?
Yes, I'm at the department using the university network. So here perhaps it is there.
Okay. I'll do one thing. I will try to log in again. In the meantime, I can just talk about my thing. Okay. What is the meeting code? Can you just repeat it? Okay. I have it.
Okay, I'll send it to you again
I
on
have it.
WhatsApp.
No.
Okay.
Okay. So this may take time because internet is not there. Okay, in the meantime, I can talk about the issue. So basically what happens is we have different kinds of situations. I will write it on the screen once my internet connectivity is established. But prior to that, if we just want to look at the different kinds of dependent variables that we come across when we are, basically doing research, you would just be able to understand what the problems are. No, I'm still offline. Okay, I'll just check what happened.
Anuradha, what I suggest is you take 10 minutes and
Yeah.
sort it out. If you want internet connectivity, I can perhaps send somebody with a dongle, which would be quick.
I think that would be safe because this is looking slightly dicey today.
Okay, then I'll send someone with a dongle.
Yeah. In the
Till
meantime,
then, you
no,
can
I can
continue your class.
talk.
It'll be
I can,
there.
yeah, I can talk till then. Yeah.
Yeah.
So basically, what happens is we have this dichotomous kind of data structure when we are looking out for something like for example, how many people would join the labor force? Okay, so suppose I want to say that I don't want to join the labor force. Means my response is what? My response is no. So let me code that response as 0. And if not, means if I say yes, I want to join the labor force, then it is what? It is a positive response. So let me code that as 1. So what is happening basically is it is a 0-1 kind of a situation. And in the 0-1 kind of a situation, what becomes to my dependent variable is it is either 0 or it is or 1. So it is not continuous. It becomes discrete. Okay, 0 and 1, 0 and 1. So if you just see the Excel sheet, which kind of has the data, you would see that in the Excel sheet you would either have zeros for my labor force participation or it would be ones. So it becomes a dichotomous variable. Similarly, I can have a situation where as Professor Belekar just said, you can have responses. So it can be a Likert scale in which 0 would represent strongly opposed, 1 will represent opposed, 2 will represent a neutral reaction, 3 will represent supporting, and 4 will represent strongly supporting. Now this, I can just give you an example. We all have these students who are agitating for offline exams, online exams, and all those things. So if I want to, collect data, if I want to collect data from the students based on this kind of a situation, there would be some students who would strongly oppose an offline exam. So they will be very clear, we will not come for the offline exam. So I will say, let me just code this as 0. Then there would be some students who would say that, no, we don't want, but if we are forced to come, then we will just come. So that is an opposition, like basic opposition kind of a thing. Then neutral means some students would say whatever it is fine with us. So that's a neutral choice. You are aware of these Likert scale this thing. So we are what are we doing? We are ranking. Actually, we are giving different numbers, not ranking. We are giving different numbers to different responses. Now here again, when you see your y variable, if you see your y variable, it will be 1, 2, 3, 4 or 0, 1, 2, 3. From wherever you have started, it will be. So this is not a continuous variable. It is discrete. It's distinctly different. Okay. This is a situation where you have to understand that the general system of a multiple linear regression model doesn't work over here. Then there can be another situation where you are just trying to look out for different kinds of categories, where some people, like if you want to see the behavior of certain people with respect to a particular situation. So maybe you have people who are clerks, who are engineers, who are lawyers, across different professions. You can code them. So the response of clerks can be given as a coding as 0. That of engineers can be given a code as equal to 1. That of lawyers given a code as 2. So like that. So again, your scale has changed. Okay, your dependent variable is no more continuous. So like this, if you just go on looking at different kinds of situations, the most important prerequisite that is that is in case of multiple linear regression models is not there. This is not continuous. So what will happen? Suppose you just ignore that your dependent variable is dichotomous, and you just go ahead with your regression model. Now I really need the screen now. Let me recheck if I can log in. So yeah, I think there is network now. Great. Yes, there is someone who has raised
Yeah,
a
madam.
hand.
Yeah, can I ask a question?
Yeah, sure,
yeah.
sure.
Yeah. So in the last example you gave of discrete categories like lawyers, engineers. So you can we safely say that, and if the dependent variable is a nominal scale, so it could be understood as an example for this.
Yes, yes. So wherever it is like, you are denoting it by a fixed number. It has to be like, you cannot say that it can be anything in this range or that kind of a structure. Is basically it requires a logistic regression kind of treatment. In fact, I feel that like, you may be because this group has a, yeah, Shehnaz also has a question. Just a second, Shehnaz, I'll get back to you. So basically, you are trying to test whether the outcome of a particular treatment is successful or a failure. Say for example, you gave a medicine, you all are psychologists. Suppose you gave some kind of treatment, whether it has given positive results or negative results, that also will come under this logistic regression kind of category. You cannot have a multiple linear regression model in that case. I will show you what is the reason behind all that. Yes, Shehnaz, can you go ahead with your question?
Yes, ma'am. Good morning. So, ma'am, in the nutshell, you are saying that both the variables has to be continuous, right? We cannot have nominal and ordinal x or y.
No. We are not talking about x at this point of time. X is not, it has not been touched. We are just talking about the Y, and we are talking about Y as a discrete variable. So it would be 1, 2, 3, 1, 2. The basic example which I am going to do today would be just 0 and 1 or 1 and 2 in the dependent variable.
So, ma'am, I'm little confused. So that means y can be either on nominal scale or ratio scale. Both is possible or no?
It is possible. A ratio will not be possible. Ratio will not be possible.
Okay, okay.
It has to be nominal. Yeah.
Hello, ma'am.
So
Hello.
yeah. Any other questions?
Yes, ma'am. Hello.
Yes. Who's it?
Ma'am, I'm Alokananda, Dr. Alokananda. Good morning, ma'am.
Yeah. Good morning.
Ma'am, my question is, if I am taking, say for example, I'm dealing with socioeconomic data and medical related data, obstetric healthcare service related data. So my question is, if I am taking Y, say for example, social backwardness index that I have calculated, and I have ranged the entire data into 3 categories. That is the high, moderate, low. And I have given code to high as 1, moderate as 2, and low as 3. That is my dependent variable, and I have taken number of independent variable for that. So can it be possible to do?
Yes, this is a classic case of multinomial model because you have 3 categories. Now,
Yes.
what I'm going to do is a binary model where I'm taking coding as 0 and 1. Over here, you have 3 categories. So it becomes a multinomial model where the interpretation and data structures are very different compared to, like, the interpretation becomes very different.
Ma'am, ma'am, it can be done, the
It
entire
can be
data.
done. It is very comfortably you can do your explanatory variables. You can just have a look at what the explanatory variables are, but you just have to remember that because your dependent variable has these 3 categories, you cannot do basic logistic regression because that is binary, which I am going to talk about. Okay,
Yes.
but you will have to look out for some kind of multinomial model.
Yes, yes. Thank you.
Yeah. So can I proceed further? I think I can share the
Yes, ma'am.
screen now. Yeah. Now, what is exactly the problem? I'll just tell you in a bit. Yeah. So this is, where I was wanting to talk about something. Please let me know if there is any connectivity issue because I will be focusing only on my screen, so I may not understand that such a thing has happened. Yeah. So basically, what I said is when we run a regression model, you have your dependent variable, you have your data on your dependent variable, right? Now this dependent, now I have got, just a second. Yeah, wherever. No, that won't open. It's slow. No. So I'll get it directly or I'll. Should I just directly get into that because then I'm safe? Yeah.
The network, the domain name is.
So what do I do from there? I'll connect.
This is actually my daughter's birthday, Ira, but instead of I, it is exclamation mark. Ira category 2506. So ये O है, zero नहीं.
ठीक है, but how do I connect it? I've never done that. That sounds. Just give me a second, friends. I'll just get back in a second so that there are no further problems. इसी में रहता है, मुझे अभी नहीं दिख रहा. No, let it be. I will manage with these two. Just leave it. Yes, I'm so sorry about it because my headphone also doesn't work over here. I just did not realize. No, you just leave it. I'll manage it. Just leave it. I'll manage. In another half an hour, my computer battery will come. In the second session, there won't be any problem.
Okay.
Yeah.
I thought this might help, but I realized I was too by
It's not.
If there's anything, should I leave it here?
It won't work now because I don't have the.
But that guy can do something. It might help. So I'm just leaving it. If you have to start, you have to press this just
And that I know.
like press
This
off.
one I have it.
And this is the
Password. Yeah.
So if you want this connection, even that.
Yeah. Can you all hear?
Yes, yes.
Yeah, I'm so sorry about this network issue from the university. We keep on confronting such problems on an everyday basis. Yeah, so basically what I was saying is we have y as our dependent variable. So you have data on this. Okay. Now what will happen is after you have run the regression, you will get your estimated y. What is this estimated y? You will get some regression parameters, beta 1, beta 2, beta 3 and all. And you will have your residual series. So basically you have all this, and suppose this is your dependent variable and this dependent variable is a discrete variable. Then what happens is if unknowingly you use a multiple linear regression model, for this kind of a system, if you run a multiple linear regression model, then what will happen is your predicted values, these values will be such that they will not be around this. What will happen is, see, what happens is if you have a 0 and 1 kind of a thing, basically 0 is here and 1 would be somewhere over here. So your observations would be somewhere here and they would be here like this. So in a multiple linear regression model, what happens is you just have a straight line regression equation that is estimated. Okay, but in reality, what is your data asking you to estimate? Your data is asking you to estimate something of this form. So this has to be basically what? This has to be an S-shape or sigmoid kind of a function that has to be estimated, but you are actually estimating a linear equation. So you are actually estimating this linear equation, which should have actually been somewhat like this. So this is what? This is a non-linear equation, and you are applying non-linear equation techniques, and so the entire estimation goes wrong. Because what will happen is, whatever assumptions and all you make will be based on this regression line, which is not correct. This regression line is linear regression line, and your regression line has to be like this. It has to be a curve, this structure. So basically, when you are making this mistake, of using a linear model for this kind of systems, you are actually estimating a linear model when you have to estimate a non-linear model. That is the most important problem that happens. Nevertheless, in many situations, if you are lucky, this still gives you results. Gives you results, but you would see that many of your predicted values of y. Now, since your y is either 0 or 1, your predicted values also should be within this range. But you would see that in this case, when you are using this kind of a model, in most of the cases, these values will not be 0 and 1. They would cross 1, Yani they will be greater than the predicted values would be greater than 1, or they may be less than 0 also, which is not what is required. And that is the reason why we get into the realm of these logistic regressions, which are very simple. Basically, there's slight mathematical or statistical input into it, but you just have to ignore some of the unnecessary details and go ahead with the process. So I'll just make the structure over here because I was not getting this pen is too smooth. So this is 1 and this is 0. And so I have data over here. I have data over here. So it would be a sigmoid kind of a structure. This kind of a thing. And instead of this is your linear probability. So this is the very beginning, and this is the first motivation for not going ahead with this kind of a linear model in a system where the data is dichotomous. So you may have a 0-1 kind of a situation, and so when you have these kind of choices, when your data has a 0 and a 1, then the first step that is followed is you give up this linear probability, linear models. It is safe not to go with the linear model and look out for something that is non-linear. This is just basically the introduction part. Now, since we cannot run a linear regression, we have to look out for something that is slightly different. Now, what is it that we look out? We look out for a probability model over here. 1 second. Yeah. So what we do is we say that probability of success. So it is like normally denoted as probability of getting a success. That is, it is denoted like this: P of y I is equal to 1. So probability that yi is equal to 1 is given by some function. Okay. So now what is this? Your data. So in your data, the probability that yi is the ith observation or the ith cross-sectional unit that you're taking into consideration. So probability of yi is equal to 1 will be some function, say for example, f of z. Now I know when we come across this kind of representations, we get completely scandalized. Please bear with me for just 5 minutes and I'll just make it very basic and simple for you. It's just for those who want to know a reason why I'm using a particular structure. So what happens is, for this f part, this function part, I need something which will give my predicted values, in the form of 0 or 1 or around this. So this is the reason why I have to tweak this function. In the linear model, there was no function over here. We were directly using the z over here. What is z? Z is nothing but equal to beta 1 x1 plus beta 2 x2. So this part which we were estimating, I'm just denoting it as z. So please don't get scandalized if you see this kind of a notation. Now we will say that in case of a logistic regression, this is equal to 1 upon 1 plus e raised to minus z. What is minus z? E raised to minus z is nothing but beta into x, that part. Okay, so this notation changes the whole story. Earlier, when you were running the regression model, you would have just said y is equal to beta 1 x1 plus beta 2 x2, and like this you would have had some disturbance term over here. But now over here I am saying that no, my model is completely different. I am saying that the probability that there is a success or a positive response, the probability for the positive response, I am denoting it as Pyi is equal to 1. When it is positive, the response is 1, is equal to this function 1 upon 1 plus e raised to minus z. Now this is nothing but, we have these distributions. I don't know whether you all are exposed to distributions. We have different kinds of distributions in statistics, and every distribution has a CDF. What is that? A cumulative distribution function. And this cumulative distribution this is the cumulative distribution function of a logistic distribution. So just if you know, in multiple linear regression models, we were assuming there is normal distribution. So instead of a normal distribution over here, I am just replacing it with a logistic distribution. And how do I denote the logistic distribution? I denote it by using the cumulative distribution function of the logistic distribution. So basically what am I doing is, I am converting my zeros and ones. Okay, I'm converting my zeros and ones into probability of success and failure. So if my probability is success, if it is success, then I am coding it as 1. And if it is failure, I am coding it as 0. Which means what? Because sum of all probabilities is always equal to 1, then the probability of failure will be 1 minus probability of success. So that is the whole thing that is used in literature. I know this may be slightly irritating if you do not want to get into this kind of stuff. And I understand, I personally feel very irritated, because finally at the end of the day, we have software packages which give us output. So we do not need to know most of these things. But I just want to tell you 2-3 things that you will come across your software package. You should be understanding those terminologies. So there is something called as odds ratio. Okay, there is something called as odds ratio. You may see, if you are using an SPSS or any package, you will get odds ratios of various regression models. Now, what is this odds ratio? Odds ratio is the probability of success. So if I just denote it as P, then the ratio of probability of success divided by the ratio of probability of failure, 1 minus P is what? The probability of failure. So this ratio is called as odds ratio. This ratio is called as odds ratio. And our logistic regression model is basically, now if I just apply what I have got over here, it becomes like this. P of I divided by, or P1, whatever, 1 minus Pi is equal to e raised to z. Finally, our expression comes down to this. Our expression comes down to this, and we are in a very comfortable situation, because what is the z, we know. If I look out for a basic simple model where I have just one predictor variable, then I will have z will be equal to alpha plus beta x, a basic model. Then just if I take the log of this expression, this will become log odds ratio will be equal to z. So either your software package will give you an odds ratio, or it will give you a log odds ratio. So you should be aware of what you have got in your regression model, or by your when you use this model, logistic regression model, with the kind of package that whatever package you must have used in the process. I will repeat this part because this is very important, and this kind of these terminologies keep coming up when you get outputs in your SPSS package and all. So you can just remember that this outcome y is equal to 1. We are saying this is a probability of success. So let me denote it as PS. And the outcome y is equal to 0. That means a particular person is not entering into the labor force, say for example, is probability of failure. Okay, now instead of writing probability of dividing success by failure, what I'm just doing is, because the total of probability is always equal to 1. So I'm saying that probability of success divided by 1 minus probability of success. that is this ratio, is the odds ratio. Okay. Now, this odds ratio is equal to e raised to z in case of a logistic regression. And what is now it is this e, it is difficult to handle the e over here, the exponential term. So we take log of the odds ratio. So the exponential term goes up. Okay. Are there any doubts over here?
Yeah, ma'am, can I ask a question?
Yes, yes. One
Yeah.
second.
Uh,
Yeah.
Yeah, in this type of research question, you ask, that how many people would join the labor force, suppose, so 0, 1 is here, it's fine, okay, means whether they will join or they will not join, the type of
0,
thing.
1. See, 1 is they would join.
Yeah, so yeah, 1 would join, 0 they would not be joining. So,
Not
but
join.
there is some sense of direction in this, okay, because the question asks how many are going to join, right, so there is a sense of direction, but when there is no direction,
No,
like,
here we don't have that kind of a question. We are just asking one person, are you joining or not joining? Are you part of the labor force or not part of the labor force?
yeah, okay, I got that. But suppose if we have a, like a thing like something where uh, both the dichotomies, okay, are equally meaningful in the sense, like here it will be a yes or no, right? But if there's a discrete variable, like for example gender, now gender may not be necessarily a dependent variable mostly, but I'm just saying for the sake of example, where male and female. So if like I'm asking a question, what is the gender of a person? So male and female does not fall in this dichotomy of like absence or presence of a response, right? So would it be applicable in this case?
See, basically it will be applicable. The way you
Okay.
look at the whole question would be slightly different. I will give
Okay.
you, maybe if you just give me an example, over here, whether I'm joining or not joining, these are different kind of events. You are
Right.
talking about a situation where you can have two equally likely events,
Yes.
right?
Yeah.
You are talking about two equally likely events, which can be, uh, uh, there, which like, over there, what is the kind of modeling technique? That is what you want to ask me.
Yeah, like for example, the earlier example you had given of the occupations, right? The lawyer, engineer. Even though,
Exactly.
yeah, there could be more than two definitely. But suppose if
Yeah.
a company was, something like that, where you had two options available, either a lawyer or engineer. Either you choose to do law or you choose to do engineering. So there are
In that
yeah,
situation, if you are continuing with a logistic regression, then
yeah,
you would have a preference for a lawyer, and you would say, if I am picking up a lawyer's profession, then that
okay,
is probability of success.
okay,
Because this is a dichotomous situation. Here we do
right,
not have any other option. So
right.
you definitely have a preference. Now it is underlying over here that I would want somebody to join the labor force. See,
Mhm.
basically, I am not talking about my preference over here. I'm not revealing my preference, but I would want to know, uh, like, I would want to get an optimistic or a positive answer when it comes to joining the labor force. So I would want to say that yes, this person is joining or not joining. So my imagination of associating a success to whether a person is joining the labor force is purely based on my imagination.
Yeah,
So
ma'am,
at that,
I got that, but my question was about preference. You used the right word actually. So my question is, if the dependent variable is preferences, for example, and the preferences are two, would this be applicable?
if you have only two preferences,
Yeah.
then you yourself can decide which one is a higher preference. That becomes the probability, because finally your interpretation will be with respect to 0
Yes.
and 1.
ಈ ಸ್ವಲ್ಪ ತಗೊಂತಿರಲ್ಲ ನಾ ಹೇಳಿಲ್ಲ ತಗೊಂತಾರ ಅವ್ರು.
Okay. Any other? Yes, there is one more question, I think. Mr. Ghosh, you have a question?
Hello, ma'am.
Yeah, sorry.
My question is, which one is the final model? Because previously you tell that f z equals to 1 by 1 plus exponential to the power minus z. And next we have come to the conclusion that probability of success divided by 1 minus probability of success when we are calculating the odd ratio explaining. So which one is the final model, ma'am?
See, I'll tell you why I'm talking about the odds ratio is in many cases the software gives you odds ratio. So this part which I'm talking about is about the odds ratio which you will get from your software. Okay, but the model which we are having is the f of z over there, which is 1 by 1 plus e raised to minus z. So basically, if you are understanding this modeling system, you would understand that from there I will go ahead with my estimation techniques, the maximum likelihood estimator and all those. Is
Okay,
it
ma'am.
clear?
And the final model is 1 by 1 plus e to the power minus z.
Yeah, because that is the cumulative density function of a logistic distribution.
Okay. Thank you.
So, the questions can be of two types. One is application oriented, where when you are using the data and you are getting some kinds of output, and there would be other kinds of question where you have technical doubts. So whichever it is, you can ask me. Yes, there is one more doubt, I think. Yes, Shami, if I can see you.
Yeah, yeah. I wanted to ask a question. See, here the dependent variable is dichotomous in nature, and let's assume the independent variable is like gender. Can we apply this kind of a logistic regression, for example?
Of course. Yes, in fact, in the example that I'm going to give, I
Yeah.
will have labor force participation rate as my dependent variable. I will have age, gender, marital status, and all those things as my explanatory variables. So you can use them like in the explanatory variables. If you have dichotomous or you have this kind of variables, you can run that regression. That is not the problem. The problem is the dependent variable.
Okay.
Okay, can I proceed now?
Yes, ma'am.
Okay. Yeah. So basically, this odds ratio part is associated with what output the software package will get, and that is why I just try to explain what this odds ratio is basically about. Now, let me just scroll down. Okay, and it is also called as the logic if the function is a logistic function. Now, when we have logistic models, when we have a logistic regression model, it is not possible for us to use OLS. Now, I do not know whether you all have exposure to these estimation techniques, but I will just briefly tell you that when you are using multiple linear regression model, basic multiple linear regression model, they have OLS estimators on. So basic models. If there are problems, then we tweak the kind of modeling techniques.
Ma'am,
Yes.
your voice is not clear. Little echo is coming.
Okay. I just kept the.
Now it's better. Yeah, now it's better.
Yeah. So basically, when we are talking about estimation, so now what has happened is you have a model and you have to estimate the model, right? So the estimation